Hi guys, in this video we're going to look at arithmetic sequences in series, and an arithmetic sequence is a sequence in which each term after the first is constructed by adding the same fixed constant. So for example, what we have here is 1, 4, 7, 10. You can see here what's happening is we are adding the same thing, the same constants to get from one term to the next. 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 3 is 10, and that would carry on and on and on. Okay, now the general definition here, in order to prove a definition of an arithmetic sequence, is if we have the first term, the second term, the third term is arithmetic, if the next term minus the previous term is equal to a constant. What does that mean? Well, you can see here, if we have a look for the first one, let's see if it is a arithmetic. We've got 9, so this is 9, take away 5, which is 4, 13, take away 9, which is 4, 17, take away 13, which is 4. So yes, this is an arithmetic sequence. So look at this one, 4, take away 2, which is 2, 8, take away 4, which is 4. They're not the same. And again, if you do 16, take away 8, that's 8. That's not arithmetic, as you can see here, that it's not a constant, it's changing. So is this one arithmetic? Yes, it is. Is this one arithmetic? No, it ain't. Okay, so let's have a look, see if these are arithmetic. So the main mistake that people make here is they just put numbers in. So for example, for this one, they'll put 1 in, and to get 4 times 1 minus 3 is 1. They'll put 2 in and then get the result, and 3 in and get the result, and then they'll notice that what's going to happen here is that the common difference seems to be 4. You know, they're adding 4 to get from one to the other. Now that doesn't actually show that it's arithmetic. It's a bit of a fudge, so we can use the definition that we had before, which is what we're saying is that t of n plus 1 minus t of n is equal to some constant, which we're going to call k. Okay, so that's what we need to be able to prove. So for the first one, let's have a look. So we've got t of n is equal to 4n minus 3, which means that t of n plus 1, that means wherever I see an n, so I look n here, wherever I see an n, I'm going to replace it with n plus 1, because we're throwing n plus 1 through this rather than just n. So this becomes equal to 4 lots of, and I'm going to put n plus 1 here, I'm going to put it in blue just to show what I've done, minus 3, and then I'm going to tidy that up. So we get t n plus 1 is equal to 4n plus 4 minus 3, which is equal to 4n plus 1. Okay, now once I have my tn plus 1, I'm just going to put the tn plus 1 there. There's my tn plus 1. There's my tn. And we know, according to the definition, that if I take tn away from tn plus 1, I should come out with a constant. So let's try that. So I'll just rewrite it, tn plus 1 minus tn should equal some constant. My tn plus 1 is this thing here. So it's 4n plus 1. A minus, and I don't forget to put everything in a bracket, so tn, so here we look, the tn is up here, that's 4n minus 3, okay, so 4n minus 3, and let's have a look, see what happens. Let's get out the brackets, we've got 4n plus 1, minus 4n, and then we've got this, so that's the minus 4n, and we've got the minus makes a plus, we've got plus 3, okay, so a double negative, and hopefully you can see here this 4n, minus 4n is going to cancel out. We get plus 1 plus 3, so that turns out to be equal to 4, which is a constant. So therefore, this here is arithmetic. So it implies arithmetic. Okay, so let's have a look at the second one. And again, what we're going to do is we've got t of n, so we'll just write that down, is equal to n squared plus 4. So that's the first one we're going to use. But now we need to find tn plus 1. Okay, so tn plus 1. So just like before, wherever I see an n, I'm going to stick n plus 1. It's a bit like just using a function. So we have n plus 1, again I'll just do it in blue for you, squared plus 4. That's equal to that. Now we're probably going to have to multiply this out, so we'll do the bracket now. That's going to be equal to n squared plus 2n plus 1 plus 4. And tidy it all up, we get n squared plus 2n plus 5. Okay, so that's my t of n plus 1. Boom, 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 boom. Okay, so we know it's t of n plus 1 minus t of n must be equal to, I'll just write constant this time, so some constant. So tn plus 1 is over here. Okay, so let's get that one first. We've got n squared plus 2n plus 5 minus, don't forget your bracket. And again, you can see here, t of n is this one here. So let's put that through. N squared plus 4. Okay, get the bracket out, plus 2n plus 5 minus n squared minus 4. And the n squares will cancel, we end up with 2n plus 1. Now, you see here that there was no n's in this, there were no variables, there was just 4. 4 is a constant. Here what we have is that we have an n, which means that we have a variable, which means there is a variable, which means it can't be constant because it's obviously going to vary as n varies. So therefore, this is not arithmetic. And if you throw a few numbers through there, guys, you'll notice that that's not going to be arithmetic. You throw a few numbers through the first example here, you'll notice this is going to be arithmetic. Okay, there's a standard notation used with arithmetic sequences and series. And what we say is A is always the first term, and D is the common difference. And if A is the first term of an arithmetic sequence or series and D is its common difference, then T of n is equal to A plus n minus 1D. Okay, there's a proof for this. Let's go through it, shall we? So I have a look at T1. So T1 is just equal to A, and that there is from this definition here. Okay. And then we end up with T2. Well, T2 is equal to A plus the common difference. So, for example, if I just give you some numbers so you can see it. So, suppose my 5, is my A. So, that's my first term, my T1. And suppose the common difference is I'm going to go up in 3s. Okay, which means that my T2 is going to be 8. My T3 is going to be 11. My T4 is going to be 14, etc, 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 etc. Okay, so my common difference here would be plus 3. So you can see here, so just to show you, that's plus 3, plus 3, plus 3, etc. Okay, so 5 plus 3 gives me 8, so that there is my D. Okay, so second term is my initial term 1, 5, plus the difference to get me to term 2. Now hopefully you can see that term 2 is equal to, term 3, is equal to my A plus my D, because that's my previous term, so that gets me to 8. But then to get to term 3, I'm going to add another common difference on this D here. So I'm going to add another difference on. Now I'm just going to come to the side here. You can see that T1 is equal to obviously A. T2 is equal to A plus D. And hopefully you can see that T3 is equal to A plus, and you've got A plus D, which is A plus 2D. Now term 4 is going to be term 3, which is A plus D plus D. So that gets us to here. So A plus D plus D. And to get to term 4, I'm going to add another D. So it's going to be plus another D. So T4 is equal to A plus 3D. Now I'm looking for the nth term, so there should be a pattern that we can spot here. So that's going to keep going. And term n is equal to, well, it's obviously A plus something. We can see A is in every single one of them. And can we spot a relationship between our term here and the number of D's we have? Well, hopefully you can see here for this first D, there's one D when when n is equal to 2. There's 2 D's when n is equal to 3 here. There's 3 D's when n is equal to 4. So notice how it's always one less than this number here. So here, look, 2, 1, 3, 2, 4, 3. So if this is n, it has to be one less, and that is n minus 1 by D. So I'll just quickly go through that again. Notice here, the A has to come through, always comes through. And then you've got 2, there's only 1 D, 3, there's only 2 D's, 4, there's 3 D's. So if there's n, there'd be one less than whatever this n happens to be. So this is 4. This is 4 minus 1, which is 3. And that there will give you the term formula. So if I want to know what any term is in this sequence, if I want to know what the 60th term is, the 80th term, the millionth term, all I need to do is I need to find out what A is, D is, and just stick the numbers in. Okay, let's have a quick look at an example for this. It says here, in an arithmetic sequence, the 4th term is 14, and the 10th term is 4 times the 2nd term. Find Tn and the value of n if Tn is equal to 1001. So there's a lot here. So let's write out the formula we're going to use. We know that T of n is equal to A plus n minus 1d. From the previous slide that we proved that was the term. And we're told that the 4th term is equal to 14, so we can say that T4 is equal to 14. Now we can rewrite T4 here using this here, because we know that Tn is equal to A plus n minus 1d. So we can rewrite T4 of this form here. Now we don't know what A is and we don't know what D is, so we just leave them in the actual equation. So T4 is also equal to A, which we don't know, plus n minus 1. Well, my n here is 4, so 4 minus 1 is 3, so that's equal to 3 by D. And now we can combine these two things. We can see that T4 is equal to 14, T4 is equal to this expression, so that means that 14 is equal to this expression here, and we can write that down. So we now know that 14 is equal to, and it's A plus 3D. And notice we have two unknowns here, so that means we're going to need another equation so that we can solve these simultaneously. So look at the other bit of information we're told. It says the 10th term is 4 times the 2nd term. So that says that the 10th term, T10, is equal to 4 times the 2nd term, so 4 times T2. And again, what we're going to do is we're going to write T10 in terms of this and T2 in terms of this, and we'll then have another equations in terms of A's and D's, and then we can solve it with this one simultaneously to find out what A and D are. Okay, so T10, looking at that, our A is still just A, so I'm just going to put a little arrow there, so that's A plus, and it's n minus 1 by D, well, that's 10, so 10 take away 1 is 9, so we get 9D is equal to, and it's 4 lots of, and T2, again, it's going to be A plus, and if you look here, the n minus 1 here, so 2 minus 1 is just 1, so it's just A plus D. So A plus D, let's multiply that out, we get A plus 9D is equal to 4A plus 4D. I'm going to take it all over to one side. I'm going to take it over to the right-hand side, the left-hand side, sorry. So I'm going to take this 4D across to here, this 4A across to here, which means I'm going to get minus 3A, okay, plus 5D is equal to 0. Now, it doesn't matter if I'd gone the other way, guys. If I'd gone the other way, then obviously this would be 3A minus 5D. It makes absolutely no difference. So now I have two equations. So I now need to solve it. So I'm just going to write one underneath the other. So I've got 14 here is equal to A plus 3D. And I've got minus 3A plus 5D is equal to 0. I need to get either the A's or the D's to have the same number in front, so I'm going to multiply, we call this equation 1, this one equation 2. I'm going to multiply this by 3. So I'm going to multiply the whole equation by 3. 14 times 3 is 42, so 42 is equal to, well, A times 3 is 3A, and 3D times 3 is 9D. So that's the first equation at the top there, multiplied by 3. Can rewrite the second equation, so it's just 0 is equal to minus 3A plus 5D, because I'm not multiplying that by anything. And now you can see that I have 3A and minus 3A here, which means if I add these together, they're going to disappear. So I'm going to add equation 1 to equation 2, so plus, plus, plus here. And if I do that, I get 42 plus 0, which is just 42. I get 3A plus minus 3A, which is 0. And I get 9D plus 5D, which is equal to 14. So what I now have is 42 is equal to 14D. That means that D is equal to 42 divided by 14. And if you do that, it's going to be 3. So D is equal to 3. Now, what I need to do next is I need to work out what my A is. So I can use any of the equations I wish. I'm going to stick it into this equation here in order to find out my A. So I'll just rewrite that. So what we have is 14 is equal to a plus 3d. I know what d is from here, so I can put that in for d here, which means I can now find my a. So 14 is equal to a plus 3 by 3. 14 is equal to a plus 9, and a is equal to 14 take away 9, which is 5. So I now have my a and I now have my d. Not quite finished the question. It says find the value of n if t of n is equal to 1001. Okay, so we know that t of n is equal to 1001, but we also know that t of n is equal to a plus n minus 1 d, because we've already shown that, and it's in your tables book in one of the previous slides. So that means that 1001 must be equal to a plus n minus 1 by d, and now we're going to try and solve that. Not as hard as you think, because we know what a is. A is 5, d is equal to 3, so we can stick it into this part of the equation here, so let's do that. So we now have 1001 is equal to a, which is 5, plus n minus 1 by d, and d is 3. Okay, so multiply by 3 at the end there. We're going to get this bracket out next, so this bracket, which is going to multiply this by 3 and this by 3. And then we're going to tidy it up, I'm going to solve it. So we've got 1001 is equal to, well, we've got 5 plus 3n, because the n times 3, and minus 1 times 3 is minus 3. 1001 is equal to 5 minus 3 on the right hand side here, so 5 minus 3 is 2. So we end up with 2 plus 3n. Take the 2 across the other side, we end up with 3n is equal to 1001 take away 2, which is 999, and then divide everything by 3, you get n is equal to 333, and we are done. Okay, so in this slide what we're going to do is we're going to prove that the sum of the first n terms of an arithmetic sequence or series is given by this expression here. S of n is equal to n divided by 2 multiplied by 2a plus n minus 1d. Okay, so what could be quite useful in maths is when we take terms and we add them together. So I'm just going to give you an example of that with some numbers, and then we'll try and get the general form for it. So suppose we have an arithmetic sequence, and we need our a and we need a d, and I'm telling you that the a is equal to 3 and the d is equal to 5. And that means that we can get the first few terms of this out using the term formula, which if you remember is Tn is equal to a plus n minus 1 d. Now remember, a is the first term, so if I just draw a few things, we've got T1 is equal to just a, which is 3. T2 then is equal to a plus d, which is 3 plus 5, which is 8. And T3 is equal to 8 plus 5, which is 13, and so on and so forth. Well, when we use the idea of the sum of the first n terms, what we're doing is we're going to add these up as we go along. Okay, so we're going to add, for example, the sum of the first one is just 3. It's just this original a here. The sum of the first two would be 3 plus 8, which would be 11. And the sum of the first 3 would be 3 plus 8 plus 13, which is 11 plus 13 would be 24. So we can write them down. So we'd have S1. So the sum of the first one is just 3, because that's where it is. The sum of the second one then is 3 plus 8, so sum of the first 2 is 11. As I said before, sum of the 3 is 3 plus 8, which is 11, plus 13, which is equal to 24. Now, what we're going to prove is just like we had the general form for Tn here, we're going to do exactly the same for Sn here. We'll have a look at the proof on how we're going to do that. So, the first thing I'm going to do is I'm just going to write down that we can say that Sn is equal to term 1 plus term 2 plus term 3, yeah, plus, and it's going to go all the way over to this side. It's going to keep adding up till eventually I'm going to get to the second to the last term, or the penultimate term, which is Tn minus 1, because it's not quite the last one, and then I'm going to get the last term there. So suppose this was 7 terms, I'd have T1 plus T2 plus T3 plus T4 plus T5 plus T6 plus T7 here, because n is equal to 7. Okay, and what I'm going to do is I'm going to start writing it in terms of how we would write the term in terms of our general formula here for the term. So term 1 we know is just a. Okay, so term 1 we know just happens to be a. So a plus, and for term 2 we essentially have a plus d. Put it in a bracket so you can see it's the second term. And for term 3, what we're doing is, if we look at this formula here, it's a plus n minus 1, so a plus 2d, which means a plus 2d, so that's how we get, 3 plus the 2 times 5, which is 13, so that's a plus 2d, okay, and that's going to carry on, so you can see there, and boom, 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 boom. And at the last one here, you can see here the very, very last one is a plus n minus 1d, so I'm just going to write that down. So that's the very last one, so that's a plus n minus 1d. And we don't want n minus 1, we want to go the previous one before that. So instead of n minus 1, which is here, so instead of this n minus 1, this previous one here is going to be a plus n minus 2d. Okay, so we're going to get plus a plus n minus 2 by d. Okay, I'm going to put a plus in there as well. We can put that in just a big bracket so you can see that that there is different to that one there. Okay, so that's what we have. And that's equal to Sn on the left-hand side. Now, what mathematicians do quite often in the proof is they will write exactly the same thing, but they'll just switch it around. Now, what I mean by that is that instead of writing T1 plus T2 plus T3 plus T4, and then all the way to the last one, I'm just going to write Tn first. So I'm going to write this one plus the next one, and instead of going from left to right, I'm just going to rewrite it from right to left. So when you think about this now, so this one is going to go underneath this A, this second one's going to go underneath here, and so on and so forth. So I'm just going to show you that now. So Sn here, I'll do this in blue so you can see it. So Sn here is equal to, and what I'm going to do now, as I said, I'm going to write it back to front. So Tn is going to come underneath here. Okay, so that's going to be A plus n minus 1 by d. And then underneath the next one, I'm going to put this one here. So this one now is going to be underneath T2. So if I do that, I'm going to get, I'm just going to put that in a big bracket so we don't get confused, plus, and I'm going to have A plus n minus 2 by d. Okay. And then for this one, using the same sort of idea, this is going to be plus A plus n minus 3 by d. Okay. And which means on the other side here, that this one here, that means that T2 is going to be underneath it, and T1 is going to be underneath this one over here. So this one here, again, so just plus, it's going to happen all the way through. And we're going to get A plus D here, because that now will be underneath term 2. And this one is plus A, because that's term 1. So just to show you, again, just so you don't get confused here. So for the first one, we had Sn was equal to T1 plus T2 plus T3. Yep, okay, all the way up to Tn. That's the red one, not a bother. And then what we did was we wrote it back to front. So my Tn now is here. My T to the n minus 1 here is here. Then it'd be T to the n minus 2 is here. Okay, and so on and so forth. And that meant that T1 went to the end and T2 went to the end but 1. Okay. Now you can see here that what I have now is I have two different expressions for Sn. And what I'm going to do is I'm going to add them together, and something pretty cool is going to happen. So I'm going to add these Sns here. I'm going to add this with the one underneath, this with the blue underneath that one, this with the blue underneath that one. And I'm going to continue doing that all the way across. So on the left-hand side here, you can see we're going to get Sn plus Sn. That means we're going to have two lots of Sn. Okay, so 2Sn is equal to, and hopefully you can see this one isn't too difficult. What we end up with is A plus n minus 1d. Well, A plus A is just 2A. Okay, so that's 2A plus, and it's just n minus 1d. Okay, so that one's done. And I'll put it in a bracket just so you can see it. That one's there done. Now, if we go and we have a look at this next one, what we end up here with is we end up with A plus D plus A plus n minus 1, n minus 2, d. So let's just work that out. I'm just going to come to the side here. So what we have is we have A plus D plus, and it's going to be A plus n minus 2 by d. Okay, so just going to write that out as it is there. Now hopefully you can see what we end up with is the A plus A, that's not a bother, A plus A is 2A, plus, and then we've got D on the left hand side here, and then we've got to multiply this out, so we've got ND, okay, so plus ND minus 2D, so the ND is this, N by D minus 2D, and we can collect a few things together here, so the A's are going to stay the same, so we get 2A, And then what we have is we have this d here minus 2d. So that's going to be minus d plus the nd. And now we're going to factorize that again. We're just going to factorize the d's here, the nd and the minus d here. We end up with 2a. And then we're going to end up with plus, and we can take the d out. So d, if we do that, we get minus 1 plus n, which is the same as 2a plus d, n minus 1, which is the same as 2a plus n minus 1 d. Now notice that this is exactly the same as this. And it's going to work for this one as well, because when I do a plus 2d plus a plus n minus 3d, this whole thing is going to happen again. And it's going to reduce down to 2a plus n minus 1d. So I'm going to get a whole load of 2a plus n minus 1d. So all of these, so this plus this is going to end up to be 2a plus n minus 1d. This plus this is going to be equal to this. This plus this is again going to be equal to this. And it's going to go all the way through. You can see this one's very straightforward. It's the same as this one over here. You can see this one over here is the same as the one we've just done. It's this one here. So it's all symmetric as we go along. So I'm going to end up with plus, again, 2a plus n minus 1d. Okay. I'm just going to put the line through and just say that's going to carry on again. So we're going to end up plus, it's going to be 2a plus n minus 1 by d. And the last one, 2a plus n minus 1d. So all of these ones in the middle, the ones that we haven't actually shown, are still going to be, or they're still going to add up to 2a plus n minus 1d. Now here's the clever part. So we know that 2sn is equal to 2a plus n minus 1d, and this keeps going on. And how many of these do we actually have? Because they're all the same. Well, we've got, when we add the two terms here for this one here, that's for t1, and we do the same for t2 and the same for t3, and we're going all the way to tn. That means that we actually have n lots of these. Okay, so that means that however many n is, that means we have, so if n was equal, for example, to 3, we'd have 3 lots of 2a plus n minus 1d, because we'd have this one, and the next one which would be underneath here. Okay, if it was 4, we can just very quickly 1, 2, 3, 4. You can see there's 4 lots of them. So there's n, tn, that means there's going to be n lots of them. So we can rewrite that now and say that 2 by s of n is equal to n lots of this 2a plus n minus 1d. We're pretty much nearly finished now. Once we've got there, we're just trying to get Sn on its own. And Sn is equal to, in order to get rid of this, multiplied by 2, we just need to divide by 2. So it's n over 2, and it's 2a plus n minus 1 by d, as shown up here. Okay, so hopefully that makes a bit of sense. Okay, so how are we going to use it? So we're going to ask some questions. It says find the formula Sn for the arithmetic sequence or series of 1 plus 2 plus 3 plus 4 plus, and keep going. Remember, in the last slide, we worked out that S of n was equal to n over 2, and it's 2a plus n minus 1 by d. That's in your tables book, boys. So look it up if you're not sure. And all we're going to do now is try and work out what's going on here. So this shouldn't be too difficult. If we look at 1, 2, 3, 4, and etc. My first term, a, is equal to 1, and my common difference is it's going up in ones. So it's just a is equal to 1, d is equal to 1. That means we can stick it straight into the formula. S of n is equal to n over 2. And we're going to get 2 by 1 plus n minus 1 by d, which is 1. Okay, we can tidy it up if you wish. So S of n here is equal to n over 2, 2 by 1, which is 2, plus n. Okay, so remember, we've got to multiply that out, n and minus 1, so what we end up with there is minus 1. Again, just slowly tidy it up. S of n is equal to n over 2 multiplied by n plus 1. And if you wanted to, you can multiply that out, or you can leave it as is. So that's the first bit done. So for part 2, it says use the formula to evaluate 101 plus 102 plus all the way to 500. So let's have a think of what S500 actually means. So let's just look at this. S500 is equal to, we're happy that's term 1 plus term 2 plus term 3 plus, I'm just going to go all the way over to the side here, and term 499 plus term 500. Now, I've got a bit of an issue in I don't want all of those terms. In fact, I only want term 101. So let's put term 100 here and term 101. I only want term 101, so I only actually want this bit, this portion here. But by using the SN formula, the SN formula takes all of this, i.e. this green bit here. Now, as I said, I don't want the sum of the first 100. So what I can do then is I can say, okay, well, if I have the sum of the first 100, that's equal to T1 plus T2 plus T3 all the way to T100 over here. So that there is going to work out that. And that's the bit, this bit here, I don't want. Which means in order to get this blue bit, I need to take this green bit here, i.e. S500, and take away this bit here, which is S100, which will leave me this blue bit here. So what I need to do is I need to work out S500 minus S of 100, and that will give me my 101 plus 102, okay, plus all the way to 500 here. So that's what I need to do. If I do that, then you can see here we already have the SN. The SN we've worked out over here. So I need to put 500 in first. So S500 is, well, N is just 500. So S500 is equal to, and if you put it in, you get 500 multiplied by 501 divided by 2. And if you work that out, you get 125,250. So that's equal to 125,250. S of 100 is equal to 100 multiplied by 101 divided by 2, which is equal to 5,050. And then in order to work out S500 minus S100, all you do is you take them away. If I take those away from each other, I get 120,200. Okay. Okay, another example here is the sum of the first 10 of an arithmetic series is 120. The sum of the first 20 terms is 840. Find the sum of the first 30 terms. Again, what we're going to be doing is we're going to be using the summation formula, which is Sn is equal to 2a plus n minus 1d. Okay, and we're going to multiply that by n over 2. So we're going to be using that formula twice, and we'll a pair of simultaneous equations. We don't know what our a is, we don't know what our d is. We're going to end up with two equations in a and d. We're going to solve them simultaneously, just like we did with the term formula earlier on. So the sum of the first 10 numbers is 120, so we know that S10 is equal to 120, which now means we can just put that into the formula. So we put this into here. So S10 is equal to 10 over 2, 2a plus, it's going to be 9d, because n minus 1 is 10 minus 1, which is d. So let's do that now. So 120 is equal to n over 2. Well, the n is 10, so 10 over 2 multiplied by 2a, which we don't know, plus n minus 1, which is 9 by d. Okay, so 120 is equal to 10 divided by 2, which is 5. So 5 by 2a plus 9d. And then we can divide both sides by 5 if we wish. So if we do that, we're going to get 120 divided by 5, which is 24. So 24 is equal to 2a plus 9d. And I don't think we can simplify that any further. So there's our first equation. We also know that the sum of the first 20 terms is 840. So we know that S20 is 840, doing exactly the same thing. So what we end up now is 840 is equal to, our n is now 20. So 20 divided by 2. We've got 2a plus n minus 1. Well, our n is 20. So that's going to be 19d. Okay, 840 is equal to 10 by 2a plus 19d. We can divide both sides by 10 to get 84 is equal to, and it's going to be 2a plus 19d. Okay, that there now is my second equation. Okay, write them underneath each other. So we've got 24 is equal to 2a plus 9d. We also have 84 is equal to 2a plus 19d. Perfect. The a's are the same, so I'm going to take the second equation from the first. There's equation 1, there's equation 2. So minus, minus, minus. 24 take away 84 is minus 60. 2a take away 2a is 0, and then we get 9. We've got minus 19, and if we do that, that's going to be minus 10d. That means that d is going to be equal to minus 60 divided by minus 10, which is 6. So 6 is equal to d. That now means that we can find out our a by sticking it into one of the equations. It doesn't matter which one. We'll stick it into this equation here. Okay. We now know that 24 is equal to 2a plus 9 by d, and we know that d now is equal to 6. So 24 is equal to 2a plus 9 6s are 54. Take that across, we end up with 2a is equal to 24 take away 34, which is 30, which means that it's minus 30, which means that a is equal to minus 15. Okay, so the starting value was negative 15. That's not a problem. We can start at a minus. It can even go down in minuses as well. So don't be worried if you get a negative number. We're not quite finished. It's asked us to find the sum of the first 30 terms. Okay, so we're nearly there. So we now know what our a is. We now know what our d is. So we now know that sum of 30 is equal to 30 over 2, because my n is 30. 2 by a, so we've got 2 by minus 15, plus n minus 1. Well, n is 30, so that means that's going to be 29 by d, which is 6. Okay, and all we're going to do is going to stick that into your calculator, and you'll end up with 2160. So s of 30 is equal to 2160, and then that question's finished. Okay, the last question we're going to do for this is, it says a sequence 4, 6, 10, 16, the pattern's continued, verify that the sequence is not arithmetic, show that it's quadratic, if the general form can be written of the form a(n squared plus b(n plus c), find the value of a, b and c. So this is something that we did in Junior Cert. Okay, so if you have a look at 4, 6, 10, 16, and it says verify it's not arithmetic. Now remember, if it is arithmetic, then what's going to happen is that the first differences will be equal. Okay, so you can see here that if we just have a look here, this has gone plus 2, this has gone plus 4, this has gone plus 6. So therefore, not arithmetic. Okay, that's a nice easy check, because remember that if we do 6 take away 4, 10 take away 6, it should be exactly the same there. Tn plus 1 minus Tn should give you a constant. So I'm going to show this quadratic. Well, in order to show something's quadratic, we look at the second differences. And if the second differences are going up by the same amount, which according to this, they appear to be doing so. So this here is the first diff, or the first difference. This here is the second difference. And if the second difference are the same, then that implies it's a quadratic. So we now know it's a quadratic. Okay, well, the rule is for the quadratic, if you're not sure, that it's of a form Tn is always equal to sum an squared plus bn plus c. And we have to find out what a, b and c are. Now the rule for a is you take the second difference and you halve it. So a is always, so this a here is always half the second difference. So you can see here the second difference that we worked out is 2. So straight away now we can say that a is equal to half of 2, which is 1, which means that we now know that t of n is equal to 1 by n squared. So it's just n squared plus bn plus c, which now means that we have two variables to solve for, the variable b and the variable c. Okay, so let's start with them. First thing we need to do now is we need to get some numbers. We need to get two equations, because we have two unknowns, b and c. N is just part of the nth term, so that's fine. We can find some numbers for that in a second, because we can put 1, 2, 3, 4, or whatever we want into that. And that will then just leave us with b's and c's. So the first thing we're going to do is we're going to put 1 through the equation. So if n is equal to 1, that means we get t1 is equal to, well, n is equal to 1, so 1 squared, plus bn, which is b, by 1. Okay, so I'll write out plus c. Now we know what term 1 is because we've been told that the sequence here is 4, 6, 10, 16. So we know that the first term, okay, so the first term is 4 because there it is, 4. 4, 6, 10, 16. So the first term is equal to 4. So we can now replace this t1 with 4. So 4 is equal to 1 squared, which is 1, plus 1 times b, which is b, plus c. And we can take the 1 across to get 3 is equal to b plus c. We now have our first equation, okay, of the simultaneous. So b and c, we just need another equation. In order to do that, what we're going to do is we're now going to put t2 through. So t2 is equal to, and this time it's going to be 2 squared from here, because remember it's from this formula here. So t2 is equal to 2 squared plus b times 2 plus c. So plus b times 2 plus c. Tidy it up. You can see that t2 is equal to 2 squared, which is 4, plus 2 times b, which is 2b, plus c. And we know, as before, that term 2 is equal to 6, so we can substitute that in. So we're going to get 6 now is equal to 4 plus 2b plus c. Take the 4 across, and we end up with 2 is equal to 2b plus c on the right hand side. And there's our second equation. Let's write one above the other. So we've got 3 is equal to b plus c. We end up with 2 is equal to 2b plus c. You can see the c's are the same, so I'm going to take the first equation, or the second equation for the first equation here. So minus, minus, minus. 3 minus 2 is 1 on the left hand side. B minus 2b is minus b. And what we end up there on c minus c is 0. So b is equal to minus 1. In order to find out c, stick it into the equation. I'm going to stick it into this equation here, which means I'm going to end up with 3 is equal to minus 1 plus c. So that means that c must equal 4. So we now know that a is equal to 1, b is equal to minus 1, c is equal to 4, which means that tn is equal to, remember it's an squared plus bn plus c, which is equal to n squared minus n plus 4. Now what we should really do is just check the first few terms to make sure this works. So let's put 1 through. So if we put 1 in for n, we get 1 squared, which is 1, minus 1, which is 0, plus 4, which is 4, and that's the first term. For term 2, we get 2 squared, which is 4, 4 minus n, so 4 minus 2 is 2, 2 plus 4 is 6, and I'll just check one more, just to make sure it's fine. 3 squared is 9, 9 take away 3 is 6, 6 plus 4 is 10, and it looks as if this is working.